I'm talking about nuclear power in connection with the new energy challenge. It's sometimes difficult to think about nuclear power as being a new energy because we've had it for 60 years, half the time that we've actually been generating electricity. But I'm addressing in particular the issues which are facing the long-term sustainability of nuclear energy as a low-carbon energy source. NNL is working across the whole fuel cycle in this area. We're looking at new fuels, we're looking at advanced reactor technologies, we're looking at recycled technologies such that we can make much better use of the natural resource that's available. The natural resource in this case is of course uranium, and we probably have about 150 years worth of uranium left at current and projected rates of consumption. The main reactor technologies for addressing the long-term fuel sustainability challenge are fast reactors. The UK has had a fast reactor program in the past, and these reactors are being developed around the world. And NNL is looking at what technologies are suitable for the UK and looking at all the associated fuel cycle facilities that are needed to support such a reactor fleet. We're working in partnership with both international organisations and European organisations through the European Commission framework programmes in particular. Organisations such as the CEA in France, KTH in Sweden are two examples. The achievements so far have been in terms of developing new fuel technologies. We are working very hard on developing accident-tolerant fuels for existing reactors. We have achieved quite a lot in the field of the recycle of nuclear fuel. In particular looking at recycle methods for proliferation resistance, such that we don't generate excess amounts of plutonium and give ourselves a proliferation challenge going forward. The biggest challenge, I think, in the short term is, biggest challenges I should say, are economics and public acceptance. Economics we believe we can address with some new reactor types called small modular reactors, which shorten the construction time and minimise the risk to utilities when they're building new power stations. But in all nuclear technologies we have to remember that the public is the main stakeholder, and we have to ensure that public engagement is at the centre of everything that we do. In NNL we've had a programme of public engagement for the past 2 years, where we've actually gone out and held workshops with local communities, particularly in the areas where we're building new nuclear power stations or planning to build new nuclear power stations in the UK. And those workshops have been very positive so far in terms of the feedback that we've had from the people who've taken part in them. The vision for the future, I think now that we have access to government funding through the money that was available in the 2015 autumn statement, £250 million over the next 5 years, which we can bid into alongside other UK organisations as well. I think that should accelerate the rate in which we can develop new reactor types and the associated fuel cycles.
The nuclear industrial strategy intends that we'll have 16 gigawatts of nuclear power by 2030 and 75 gigawatts by 2050. The choices that we have for a 16 gigawatt fleet are somewhat different to a 75, and the purpose of this project is to explore what is the best options for the UK. There are lots of reactor options available to the UK in the future, and the NNL is exploring what the benefits and challenges associated with different reactors and fuel cycles are. Historically, the UK has been interested in sodium-cooled fast reactors, so we've been exploring what the benefits and challenges associated with sodium-cooled fast reactors with reprocessing would be on uranium utilisation and the repository. We've only explored sodium-cooled fast reactors so far, so the intention in the future is to explore other reactors and different ways of operating fast reactors. So far we've looked at sodium-cooled fast reactors, but obviously there are lots of other reactors out there and different ways of operating those reactors. So the next steps would involve exploring how fast reactors, for example, could work in tandem with an existing light water reactor fleet. We're also interested in looking at small modular reactors and what the benefit of a small modular reactor might be for the UK.